This video is going to go over how to draw Lewis structures for compounds that follow the octet rule. So we're going to start off and talk about what a Lewis structure is, the different parts of it, go over the steps of how to draw it, and then we're going to actually start drawing them together. So by the time you are done with this video, you will be able to draw Lewis structures. Up first, let's talk about what a Lewis structure is. A Lewis structure is a diagram that shows the bonding or the bonds between atoms of a compound. And so we're looking at those bonds between the atoms within a compound, but not only are those bonds important to us, but also the lone pairs that exist. You remember a lone pair from when we talked about Lewis dot diagrams? For example, if you had nitrogen, nitrogen's Lewis dot diagram looks like this. Right here, this would be a lone pair. And then all of those other electrons you see here, 1, 2, and 3, those are single electrons. Those single electrons also go by another name. And that other name, these are called free radicals. And we're going to talk about those later. Free radicals are really bad, 1, for your health, and 2, for Lewis structures. So these diagrams, all of the atoms, except for hydrogen, within a diagram that we're going to be drawing, these Lewis structures, they really want access to 8 valence electrons. And that's not new information. This is called the octet rule. And we've been learning about this for a while now. The octet rule says that all atoms really want 8 valence electrons because it helps them become stable like a noble gas. That is a full valence shell. Let's talk about the different symbols you are going to see within a Lewis structure. Up first, we have dots. So if you see a dot, that is going to represent a valence electron. Next, if you see a single line, that is considered a single bond. And a single bond represents 2 valence electrons. I'm going to put VE for valence electron. A double line then is a double bond. And if one bond, one line, single line, represents 2 valence electrons, then if you have a double bond, we are representing 4 valence electrons. And then lastly, a triple bond, that would represent 6 valence electrons. So those are the symbols that you need to know. Let's talk through the steps. Step number 1, we want to determine the type and number of atoms in the molecule. So for example, we have H2O right here. So the type and number of atoms in a molecule, our type, we have hydrogen and we have oxygen. That would be the type. The number of atoms, that comes from the subscript. Hydrogen has 2, so H2. There are 2 hydrogens within H2O, and there's 1 oxygen. The next thing we would do would be draw a Lewis dot diagram for each atom. So we've got 2 hydrogens, and we have 1 oxygen. The next thing that we have to do is we have to figure out which one goes in the middle. If carbon is around, carbon will go in the middle. Carbon loves to be the center of attention. It is in the middle of everything. However, if that's not the case, whatever has the most single dots goes in the center. So most single valence electrons goes in the center, which means oxygen is going to go in the center. So I want to show you a picture of this similar to the activity we already did. It looks like this. And this is very similar to what we just drew, just arranged differently. So whenever you're drawing Lewis structures, our single dots are going to match up. And what happens is these single dots, they form a bond. So if something is already a lone pair, like those 2 are, they do not form bonds. So lone pairs do not form bonds. However, single electrons will. So these single electrons do form bonds, and they want to form bonds. From our notes just a second ago, we said that a single line, a single bond, is equal to 2 electrons. So that occurs right here. These 2 electrons are going to create a bond. So will these two, because they matched up. So what we can do is take this matching that we see and we can turn it into a Lewis structure. I'm going to erase this so we have some room to write. So if we were to draw this as a Lewis structure, we're going to keep the elements that we see, H. We have O over here and another H down here. These 2 electrons are going to form a bond, so we're going to replace it with a line. Be sure, after you draw a line, do not draw the dots. So this would be correct. Something like this is incorrect. We don't draw it like that. The other bond is here, so we'll draw a line. And then you include lone pairs in your drawing, and we have lone pairs here and here. And that is our Lewis structure for water. So let's go back to our notes and write that down. So to pick up with the steps, step number 3, to determine what goes in the center, we knew that oxygen was going to go in the center because it had the most single dots. And then to match up around, we know this one is going to come over here and this one comes over there. And just like our other picture, our Lewis structure for water looks like that. So we drew the Lewis structure, so all the single electrons were paired up. We used single bonds this time, and then we need to make sure that everything has access to 8 valence electrons, except, for hydrogen, that really just needs access to 2, so it become like helium. Oxygen has access to 8 electrons because it has 2 here, 2 here, so that's 2, 4. And then this bond represents 2, that's 6. This bond represents 2, that's 8. So oxygen has access to 8 valence electron. Hydrogen has access to 2 because that bond represents 2, and then this bond represents 2. The last thing is to just make sure as well that no free radicals are present, which means we don't have any just leftover electrons, any leftover single electrons. And we meet all the criteria for that. So let's try another one. Our next one is CH4. We determine the type and number of atoms. There's 1 carbon and 4 hydrogen. Let's list our pieces off to the side. And then to figure out what goes in the middle, now we're on step 3, the most single valence electrons does, and that's carbon. Carbon also likes to go in the center. And then we can match up these single dots so they go around it. Let's look at a picture of what we did earlier. So when we match up these single dots, we can see the Lewis structure starting to take shape. We can put one of the hydrogens above it, one on each side, and one below it. And then our single dots become bonds. So it ends up looking like carbon in the center. Up here, we have a line. Over here, we have one. And then below it and next to it. And that's our Lewis structure for CH4. Let's go back and draw that. So carbon went in the center, and then these hydrogens went all around it. And it looks like that. Number 5, make sure everything has access to a full valence shell except for hydrogen, and we have no single electrons. Check. Carbon has 2, 4, 6, 8, and then hydrogen has access to 2 each. Our next example is CO2, and things get a little bit more complicated here because this one's going to have a double bond. So if we list out what we have carbon has 4 singles, and then we have oxygen, we have 2 of them, like this. So when it comes to arranging it, most single dots goes in the center. Carbon also likes to be the center of attention, so we know that carbon's going to be in the center. This next one we're going to do is just kind of a rough draft to show how this works out, and then we'll draw a final one off to the side. So carbon's going to hang out in the center. We only have 2 oxygens, but each of the oxygens have 2 single dots, which means between those 2, we have a total of 4 single dots. And if we look at carbon, it has a total of 4 single dots. So we are going to take this oxygen and move it up here, and we're going to take this oxygen and move it over here, but rearranging the dots so that it matches up a little bit better. So that one oxygen comes above it, and then the other oxygen, we're arranging the dots so that it matches up better, comes over here. So now hopefully it's a little bit easier to see how this matches up. These two form a bond, and these two form a bond, and then these two form a bond, and these two form a bond. So if we draw that now, we don't want to draw the lines off to the side. That would be sloppy. So we're going to draw them very nice and neat in the center. And instead of drawing it at an angle like this, I'm just going to draw it sideways, and that's fine too. So you can imagine this whole thing just rotating to the side. So we have carbon, then a double bond to O, and then on the other side, double bonded to an O again. If we were to have drawn it off to the side, it just would have looked like this. So just in case that's tripping you up a little bit. And then all we did was just rotate it around. So this one was different because we had double bonds. Carbon has 2 double bonds coming off of it, but all of the electrons are represented. And to double check on those last steps, carbon has access to 2, 4, 6, 8 valence electrons, and each of the oxygens, 2, 4, 6, 8, and same on the other side. For this next example, why don't you do the first couple steps on your own? So go ahead and pause the video and try this one, just the first couple steps on your own. Okay, for the first couple steps, you had N2. Each of the N's look like this. And then you had F4, so 4. Sorry, that's a little bit sloppy there. Okay, so when we're putting this together, we need something with the most single dots in the center. Well, fluorine, each of those fluorines only has 1, but both of our nitrogens have 3 single dots. So they're actually going to split the center then, and they'll look like this. So it's really easy to see that these are going to already match up. And then we have 1, 2, 3, 4 single places left. And it just so happens that we have 4 fluorines with a single dot. So each of those fluorines are going to go to our nitrogen. So let's redraw this a little bit neater. So now everything is arranged perfectly. We can see this forms a bond, this one does, this one, and our last one right here forms a bond. So now what we're going to do, we're just going to draw bonds instead of our electrons. And it looks like this. Notice when we draw those bonds, we keep the electrons around it. Nitrogen retains its lone pair, and fluorine retains its lone pairs. We have 2 more examples on here. Pause the video and give these both a try. So pause and try BCl3 and CH2O. Okay, I'm gonna go over our last 2. Hopefully you're picking this up a little bit more. For our first one, boron has 3 valence electrons. We have 3 chlorines, and they each have 7 valence electrons. So then trying to determine which one goes in the center, these chlorines only have 1 single electron, but boron has 3. So boron wins, it gets to go in the center. So our structure will look like this. Don't forget to have your lone pairs around chlorine, but your structure should look like this. Should also note that it's okay if instead of chlorines being this direction, if you have, let's say, this chlorine on this side, that's okay too. Or maybe, instead of having this one on the bottom here, you drew it on the top and you had it like this. That's fine as well. You just want to make sure that there are 3 single bonds coming off of that, met by your 3 chlorines, and that all of the lone pairs are there as well. For CH2O, we have 1 carbon, 2 hydrogens, and 1 oxygen, and this is probably the most difficult one on here. For this one, most single dots wins in the center. That's carbon. Whenever carbon's around, it likes to be the center of attention. So carbon has 4 single dots. These hydrogens each have 1, so we'll just pair those up on the edge like that. And this leaves 2 single dots. We've used this, we've used this, we've used that. Carbon still has these 2 single dots that need to be bonded with. Just so happens oxygen has 2 single dots, so oxygen is going to be up here. It's sort of a diagonal from it in order to match up. So these match and these match. So now we can see where all of the bonds need to be drawn. The bonds between carbon and hydrogen will be single bonds, and the bond between carbon and oxygen is going to be a double bond. So I'm going to draw this one off to the side a little bit neater. We have hydrogen, hydrogen, and then a double bond to oxygen. Always make sure your double bonds are nice and neat like that as well. All right, let's do a recap of Lewis structures. So Lewis structures, we're just looking at a diagram that shows the bonds between atoms of a compound, and we're looking at lone pairs as well. And we're drawing these, we gotta make sure they follow the octet rule. You now know those symbols and what they mean. In terms of the steps for drawing them, we started off with just how many of each atom we have. We drew the Lewis dot diagram for each. Most single dots goes in the center, and we pair them up, draw single, double, or triple bonds as needed, and then make sure there are no free radicals remaining. All right, that is it for Lewis structures.